The possibilities of the future are exciting.
This was considered like an impossible technology.
Wow, I mean, so this is the future, really, isn't it?
Pioneering tech that can help outside the body is one thing, but there is a large field of work looking at using tech inside the body. There have already been trials of chips that can be implanted to treat specific conditions, including sight loss, where they have enabled people to regain a small amount of sight, which is something that I wouldn't consider yet. There is a world where technology could restore eyesight, but I think it's one of those things that it would have to be good enough to be life-changing. It'd have to be enough to provide true independence, make a real difference. When you're in the last dregs of your eyesight, you know, you're always trying to cope with something that isn't good enough anymore. If you were to say, do you want enough sight back that I had when I was 20? Not really, no. Because, you know, having to depend on a small amount of eyesight can be more problematic than it's worth. Here at MIT, they have made a breakthrough that could change healthcare for all of us. Led by Professor Deblina Sarkar, a transdisciplinary innovator, they are bridging the gap between nanotechnology and synthetic biology. At the Nano-Cybernetic Biotrek Lab, what a name, Deblina and her team are using the very latest in nanotechnology to do something only previously conceived of in science fiction movies. Here, they are developing minuscule devices that are smaller than a human cell and invisible to the naked eye. The aim is to inject them into the body to treat various conditions without the need for surgery.
It's the coolest name for a lab, first of all.
Thank you so much.
Nano means small, cybernetic means chips that work with the human body, and biotrek, I'm guessing, means they travel inside the body. Am I close?
You're very, very close. So you are probably one of the first person to, you know, get the name like right.
I've been practicing it outside for 3 hours.
So yeah, nano means small. Specifically, it means nanometer.
Yeah.
So if we take a strand of hair and divide the thickness 10,000 times.
A 10,000th of a hair.
So very, very tiny things which you cannot see with naked eye.
Wow, I mean, so this is the future, really, isn't it?
Yeah, actually the goal of my lab is to fuse this nanoelectronics with biology for healthcare, specifically to reduce human suffering and treat diseases such as Alzheimer's, Parkinson's.
The hope is that the devices Deblina is creating can be targeted to specific parts of the body, travelling through the bloodstream and implanting themselves where needed, then tuning the body's electrical signals to restore the function of damaged cells and potentially slow the spread of disease. So far, it's only been tested in animals, but the possibilities of this tech are revolutionary.
Our first thing that we are doing is treat diseases related to the brain. Brain cancer, for example, what we have shown in our animal work is that by precisely modulating bioelectricity in the tumor environment, you can actually completely halt the growth of tumor. I want to scale this technology and get it to clinic, I know, as soon as possible, but we are also doing it like very responsibly as well. We really want to make sure that, you know, when you go to clinical trials, you know, if it's something that can, you know, really work, right? Yeah. Now it's time really to scale it up, do the implementation, like get the FDA approval so that we can start the clinical trials. We believe in the next 3 years.
3 years?
Yeah.
This is a documentary in itself, isn't it?
While her early work has related to cancers, another area that Deblina is researching is using these nanodevices to treat sight loss.
I've got an eye condition, a disease, so the retinal cells die off slowly over time. So these nano chips that you're creating, would they almost be something that would replace photocells in the eye? Or if you're talking about my condition?
Yeah, absolutely. Because these devices can harness this light that falls on the eye. They can convert it into electrical signals which can be sent to the brain. So though those specific cells are destroyed, we can actually send the information a person would otherwise see to the brain. So it totally bypass those degraded cells. It's possible that a person can still get the vision back even when those cells have been destroyed.
Each of these devices or chips would almost individually replace photoreceptor cells. So
Yes.
a lot of them would be sent in to
Yes.
attach to
Yeah.
a retina.
Yeah, so the resolution we can get is in fact even better than what a person with eyesight can resolve.
So you're saying not only you reckon at some point in the future you could restore my vision, but you could make my sight better than everybody else's.
Exactly, it can augment humans beyond what biology provides, and you can do other things like we can add night vision, for example.
It does sound like crazy science fiction, though. It's like
Yeah,
to say we've got devices 10,000th the size of the width of a human hair. You can put it in the body. It knows where it's going. It knows what it's doing when it gets there.
Yeah.
And it can fix problems, make you see, make you think better, cure diseases.
Deblina and her team are yet to undertake human trials. But if they can show the same encouraging results they did in their animal work, then this could be game-changing. Not just for me, but for all of us. And that is something I did not expect to find when I set out. I've always been of the opinion that if you're going to restore sight, you need to do it biologically because you're restricted by technology. You know, you don't want something that's going to be obsolete. But I'd never really considered that technology could be used on a cellular level. So it's something I'd never considered in that regard before. I came into this thinking it was the far future, and it's not as far as we thought, is it? It's kind of just around the corner.